Hello students, welcome to Edora. I am your physics mentor Umesh Sir, and today I would like to discuss the previous year question of the rectilinear motion. So here is our first question. If a body loses half of its velocity on penetrating 3 centimeter in wooden block, then how much will it penetrate more before coming to the rest? And the options are option A 1 centimeter, option B 2 centimeter, option C 3 centimeter, and option D 4 centimeter. So let me discuss the situation. Suppose here we have a wooden plank, okay, and a body, it is going to lose half of its velocity. Means suppose the body, it is going to strike this wooden plank with the velocity v. So in this case I can say v, it is the initial velocity. Then the body, it is going to cover certain distance, okay. This distance is equal to 3 centimeter, okay, or I can say S1 is equal to 3 centimeter. Now what happens during this motion? The velocity, it becomes half, so it becomes v by 2, and finally the body, it comes to the rest, okay. So finally here the body, it comes to the rest, the velocity, it becomes 0. So what about this distance S2? We have to find out this S2. Remember one thing, whenever we are discussing the motion, we have only three equations. V is equal to u plus at, S is equal to ut plus half at square, and v square is equal to u square plus 2as. Now here the initial velocity is given u is equal to v, and the final velocity, I can say v final is equal to v by 2, and the distance covered, it is 3 centimeter. So now I can calculate the acceleration, or I can say the negative acceleration, that is called as what? Retardation, by using the formula v square is equal to u square plus 2as. V, it is the final velocity, so here it is v final, so it is v by 2 the whole square. Initial, it is v square plus 2a, acceleration we don't know, so I can write down 2a into s, the distance covered, it is what? 3 centimeter, okay. So v by 2 the whole square, so it is v square by 4 is equal to v square plus 6a, 3 2s are 6a. So now I can rearrange the things. 6a, or I can say minus 6a, is equal to v square minus v square by 4. So it is 4v square minus v square divided by 4. So that is nothing but what? Minus 6a. 4v square minus v square, so it is 3v square. So minus 6a is equal to 3v square by 4. 3 1s are 3 2s are. So minus 2a is equal to v square by 4. Therefore, a is equal to minus v square by 8. The negative sign indicates that it is the retardation, because it is going to oppose the motion, okay. So here I have got the first quantity, the acceleration of the body. Now again come back to this situation. where the initial velocity it is v by 2. Final velocity it is 0 and the acceleration a, it is minus v square by 8. Now I can find out the S2 by using the same concept. What is the formula? V square. What is V? Final velocity. When the body comes to the rest, finally, the final velocity is what? 0. So it is 0 square is equal to U square. What is U? It is nothing but initial velocity. That is what? V by 2. So it is V by 2, the whole square, plus 2a into S2. So I have to find out this S2. So V by 2, the whole square. So it is V square by 4 plus 2 into A. What is A? It is minus V square by 8. Okay. So it is minus V square by 8 into S2. So now I can find out the S2. So it is 0 is equal to V square by 4 minus V square by 4 into S2. So now I would like to rearrange the term. So it is V square by 4 S2 is equal to V square by 4. So V square by 4, V square by 4, it get what? Cancelled. So S2 is equal to 1 centimeter. So the correct option is option A, 1 centimeter. Okay. So student, here we have the next question. A car moving with a speed of 50 km per hour can be stopped by brakes after at least 6 meters. If the same car is moving at a speed of 100 km per hour, the minimum stopping distance is, and the options are option A 12 meter, option B 18 meter, option C 24 meter, and option D 6 meter. Okay. So it is given the velocity of the car V1 is equal to 50 km per hour. And what is the stopping distance, the minimum stopping distance? S1 is equal to 6 meter. Okay. So now the velocity it is going to change. So V2 is equal to 100 km per hour. So what is the minimum stopping distance? S2. Clear? Now if the car it is going to stop, the final velocity of the car is equal to 0. So now I can say by using the formula V square is equal to U square plus 2AS. So final velocity it is 0 is equal to U square, that is what? Initial velocity. So it is 50 km per hour. Okay. And 2AS. But the acceleration it is what? Negative. Okay. So V square is equal to U square. So it is 50 km per hour the whole square plus 2AS. So in short I can say 2AS it is negative. So on the left hand side it becomes not positive. It is 50 km per hour the whole square. So this is for the first case. So in short I can say the stopping distance it is directly proportional to V square. Okay. So I can say S1 is directly proportional to V1 square, and that's why S2 is directly proportional to V2 square. Therefore S2 upon S1 is equal to V2 upon V1, the whole square. S2 we have to find out. S1 it is mentioned how much it is 6. V2 finally it is 100. Initially it is 50. So square of that. So 100 upon 50. So it is 2. So 2 square, that is what? 4. So S2 by 6 is equal to 4. Therefore, S2 is equal to 6 into 4. So that is equal to 24 meter. So the minimum stopping distance in the second case, it is 24 meter. So the correct option is option C, 24 meter. Now we have the next question. Three forces starts acting simultaneously on a particle moving with a velocity v. These forces are represented in magnitude and direction by the three sides of the triangle ABC as shown in the figure. The particle will now with the velocity, options are option A, the velocity v remains unchanged, option B, it is less than v, option C, it is greater than v, and option D, the mode of v is in the direction of the largest pore BC. So first of all, let me draw the diagram. The first force, it is acting from C to A, it is downward. Then the second force, it is acting towards the right from A to B. And the third one, it is acting from B to C. So these are the three forces which are acting simultaneously on the body. So first I am interested in the resultant force acting on the body. So suppose F1, F2 and F3. Now see, all these three forces are in the order and they are going to complete the triangle. So what is going to happen? So in this case, I can use the triangle law of vector addition and I can find out the resultant force. So the first force F1, it is from C to A. Second force F2, it is from A to B. Then what is the resultant of this? According to the triangle law of vector addition, I have to draw the vector from starting point of the first. Okay. So I am going to draw the vector from starting point of the first to the end point of the second. Okay. So this is the resultant. F1 plus F2 in vector notation. But this resultant, it is exactly equal to F3. Clear? The magnitude it is same and the direction it is opposite, or I can say F1 vector F1 plus vector F2 minus vector F3. Why minus? Because they are oppositely directed. So that is equal to 0. And we know that as the net force acting on the body, it is 0. What is the force according to the Newton? Force is equal to mass into acceleration. As the force, it becomes 0. Mass can never be 0. So A must be 0. Acceleration, it must be 0. And what is the definition of the acceleration? It is the rate of change of velocity. And as the acceleration is 0, we can say there is no change in the velocity. So the velocity, it remains unchanged. So the correct option is option A, the V remaining unchanged. Now we have the next question. A ball is released from the top of the tower of height h meter. It takes t seconds to reach the ground. What is the position of the ball at t by 3 seconds? Options are option A, 8h by 9 meter from the ground. Option B, 7h by 9 meter from the ground. Option C, h by 9 meter from the ground. And option D, 17h by 18 meter from the ground. So let me draw the diagram. Suppose here we have the tower, and the height of the tower, it is h. Now from this height we are going to drop the ball, or we are going to drop the stone, whatever it may be. And if the body it is released, so the initial velocity u is equal to 0. The distance covered by the body s is equal to h, okay, and the time taken is equal to t. So initial velocity is given and the time taken it is given and the s is given. So I can use the formula s is equal to ut plus half at square. So s is equal to ut plus half at square. But what about the initial velocity? It is what? 0. So s is equal to half at square. But what is s? It is h, height of the tower. So h is equal to 1 by 2 a t square. Okay. So now I can calculate the a in terms of t and h. So a is equal to 2h by t square. Okay. So a is equal to 2h by t square. Now the second part. What is the distance traveled by the ball here in the t by 3 seconds? So now s it is unknown. S is equal to ut plus half a t square. But now t it is t by 3 and the acceleration we have already calculated, so it remains the same. So s we have to find out. The term ut it becomes 0. Why? Because the initial velocity it is 0. So s is equal to 1 by 2 a. What is a? It is 2h by t square into small t. What is small t? It is t by 3. So t by 3 the whole square. So it is t square by 9. Okay. So t square it get cancelled. 2 it get cancelled. So it is h by 9. So s is equal to h by 9. But it is h by 9 from the top. So from the ground, what is the total height of the tower? It is what? H. So it is h minus h by 9. So it is 9h minus h. So it is 8h by 9. So the correct option is option A. It is 8h by 9 meter from the ground. Now we have the next question. A car traveling with a speed of 60 km per hour can stop within a distance of 20 meter if the car is going twice as fast. So that is 120 km per hour. The stopping distance will be. And the options are option A 60 meter, option B 40 meter, option C 20 meter, and option D 80 meter. So what is given? Initially the car it is traveling with a speed of 60 km per hour. And in that case, the stopping distance of the car, so I can say S1 is equal to 20 meter. In the second case, the velocity it is doubled and now it has become 120. So V2 is equal to 120 km per hour. So now what is the stopping distance in this second case? So S2 I have to find out. What is the kinematic equation? V square is equal to U square plus 2as. Okay. Now in both the cases, the final velocity, it is what? 0. So I can say the stopping distance and the initial velocity, they are what? Directly proportional. But it is what? The initial velocity square, it is directly proportional to what? S. So now I can say it is V1 square upon V2 square is equal to S1 upon S2. Now the value of S1 it is given, and V1 and V2 it is also given. V1 it is 60, V2 it is 120, S1 it is 20, and we have to find out S2. Okay. Now 60 upon 120 the whole square. Why? Because V1 square upon V2 square is equal to S1 upon S2. So 60 by 120. So it is 1 by 2 square. So it is 1 by 4 is equal to 20 upon S2. Therefore, S2 is equal to 20 into 4. So that is equal to 80 meter. So the correct option is option D, 80 meter. The stopping distance is equal to 80 meter. Now we have the next question. A car starting from the rest accelerates at the rate f through a distance s and then continues at a constant speed for time t, and then decelerates at the rate f by 2 to comes to rest. If the total distance traveled is 15s, then s is equal to, and the options are option A, s is equal to 1 by 4 ft square, option B, s is equal to 1 by 72 ft square, option C, s is equal to 1 by 6 ft square, and option D, s is equal to ft. So let me draw the diagram. A car starting from the rest means u is equal to 0. Then the car, it is going to accelerate at the rate f. So A is equal to f, and during this the distance traveled by the car, it is s. Okay. So this is my first part. Now it is moving with a constant speed for a time t. So here my second part, it is moving with a constant speed and the time is equal to t, and after that the driver applies the brake, but the retardation, it is, or I can say A is equal to minus f by 2, and the total distance covered by the car, this total distance covered by the car is equal to how much? It is 15s. Then find out the value of s. Okay, so this is the scenario. Okay, so u is equal to 0. So now I can use the third kinematic equation. V square is equal to u square plus 2as. U square plus 2as. Initial velocity, it is 0. So v square is equal to 2as. So v square is equal to 2. Acceleration, it is f and s. Or I can say, so v is equal to root 2 fs. Okay. So this is the velocity at the end of the first distance when there is acceleration, and now there is no acceleration. Car, it is moving with a constant speed, and that speed, it is root 2 fs, and the time, it is t. So s dash, what is the s dash? the distance covered during this second half, where we can say the speed, it remains constant or acceleration is 0. So this distance, it is root 2 fst. And now we are moving towards the third part, s dash dash. Now s is equal to ut plus half at square, or even we can find out v square is equal to u square plus 2as, and we can find out this s. So v, it is the final velocity, so that is the better formula, and final velocity, it is 0. So I can say v is equal to 0. U, it is the initial velocity, that is root 2 fs. Just now we have calculated, and we are interested in the s dash. So by using the formula, v square is equal to u square plus 2as. What is v? The final velocity is equal to 0. U square 2fs. So it is 2fs because it is in the square root. So the square, it becomes 2fs plus 2a. A, it is f by 2, but sign, it is negative. Why? Because it is the retardation into s. So 2, 8 get cancelled. So now I can rearrange the things. Minus fs is equal to 2fs. So minus, it become plus on the left side. So f, it get cancelled. So s dash, this new distance s dash is equal to 2s. The distance covered in the first part, it is s. The distance covered in the last session, it is 2s. So the distance covered in the middle part, it is 15s minus 3s. So it is 12s. But this 12s must be equal to root 2 fs into t. So squaring both the sides. So 12s square. So it is 144s square is equal to 2fs into t square. So s and s square. So the power, it get cancelled. 2 and 144, so it is 72. So s is equal to 1 by 72 f into t square. So in this case, the correct option is s is equal to 1 by 72 f t square, the option B. And what is option B? S is equal to 1 by 72 f t square. So that is the correct option. Now we have the next question. The relation between time t and the distance x is given by t is equal to ax square plus bx, where a and b are constant. The acceleration is, and the options are option A 2a v square, option B minus 2a v cube, option C 2b v cube, and option D minus 2a b v square. So what is given? The relation between the time and the distance is given. So I can write down t is equal to ax square plus bx. Okay. So now I am going to differentiate this term with respect to x. So dt by dx is equal to 2ax plus b. So this is my equation number 1. But what is velocity? V is equal to dx by dt. So the reciprocal of equation number 1, it is the velocity. So I can say V is equal to 2ax plus b raised to minus 1. So this is my equation number 2. Now I have to find out the acceleration. What is the acceleration? It is v dv by dx. So a is equal to v dv by dx. So that is equal to 2ax plus b raised to minus 1 d by dx of 2ax plus b raised to minus 1. So now I can find out the acceleration. It is 2ax plus b raised to minus 1 into 2a, but the sign it is what? Negative, upon 2ax plus b the whole square in the denominator. Okay, so now I can adjust the power. So a is equal to 1 upon 2ax plus b into minus 2a upon 2ax plus b square. So in the denominator we have what? 2ax plus b cube. So a is equal to minus 2a upon 2ax plus b the whole cube. But that is nothing but what? Velocity. V is equal to 2ax plus b raised to minus 1. So here it is minus 3. So a is equal to minus 2a v cube. So the correct answer is option B. It is minus 2a v cube. So student, here we have the next question. A ball is dropped from the bridge at the height of 176.4 meter over the river. After 2 seconds, a second ball is thrown straight downward. What should be the initial velocity of the second ball so that both hit the water simultaneously? And the options are option A 2.45 meter per second, option B 49 meter per second, option C 14.5 meter per second, and option D 24.5 meter per second. So let me visualize the situation. Here we have the bridge. It is at the height of the bridge. It is 176.4 meter. Okay. Now I have dropped the ball from this height. So initial velocity is equal to 0. Okay. And now the distance covered is equal to 176.4 meter. And the time taken is equal to 2 seconds. So S is there, T is there, U is there. Okay. So now we can find out the second case. What is the second case? The second ball is thrown from here with some initial velocity, and this ball, it is going to strike. Okay, it is going to strike the surface, and it should strike the surface at the same time. Okay, and it is thrown after 2 seconds. So first I would like to calculate the time taken by the ball to travel the height of the bridge, the first ball, which is a case of free fall. What is the formula? S is equal to ut plus half at square. So S is equal to ut plus half at square. Now S it is given. It is 176.4. The initial velocity it is 0 plus half a. 9.8 into t square. Okay, so now I can find out t square. It is 176.4 into 2 divided by 9.8. So now the square root of this, so that is what? Time t. So t is equal to square root of 176.4 divided by 9.8 multiplied by 2. So it is 18 za. 9.8 multiplied by 18, so it is 176.4. 18 2 za 36. So t is equal to square root of 36. So t is equal to 6 seconds. So the ball will take 6 seconds. So I can say t1. The time interval in the first case, it is 6 seconds. But what about the second case? The ball, it is thrown after the 2 seconds. So the time interval, it must be 4 seconds. So t2 is equal to 4 seconds. So now I can use the same formula. S is equal to ut plus half at square. S is equal to ut plus half at square. What is S? It is 176.4. U we have to find out into t. So it is 4 plus 1 by 2 a. It is 9.8 into t square. The time taken, it is what? 4. So 4 square. So it is 16. Okay. So 176.4 is equal to 4u plus 8 into 9.8. Okay. 8 into 9.8. So now I can say 4u is equal to 176.4 minus 8 into 9.8. Okay. Now just now we have calculated 176.4. It is 18 times of 9.8. So it is 18 minus 8 into 9.8. 18 minus 8, it becomes 10. 10 into 9.8. So it is 98. So that is 4u. Therefore, u is equal to 98 divided by 4. So that is equal to 24.5 meter per second. So the correct option is option D, 24.5 meter per second. Now we have the next question. A scooter sees a bus 1 kilometer ahead of him moving with a velocity of 10 meter per second. With what speed the scooter should move so as to overtake the bus in 100 seconds? And the options are option A 10 meter per second, option B 20 meter per second, option C 50 meter per second, and option D 30 meter per second. So we have the bus over here and we have the person on the scooter over here. Suppose A and B. The person on the scooter, it is A, and the bus, it is B. What is given? The distance between the scooter and the bus, it is 1 kilometer, means 1000 meter. Okay. Now the bus, it is moving ahead with a velocity of, so I can say velocity of bus, it is 10 meter per second. Okay. And within how much time interval, yes, the person has to overtake the bus? T. T is equal to 100 seconds. So the time interval, it must be 100 seconds. So now I can say the relative velocity between A and B. It is nothing but VAB is equal to the distance. How much? I can say distance upon time. So this distance, the relative distance, it is 1 kilometer. So it is 1000 meter divided by time, it is 100 seconds. So it is 10 meter per second. So that is the relative velocity of A with respect to B. So VAB is equal to 10 meter per second. But what is relative velocity? It is VA minus VB. So VA minus VB is equal to 10 meter per second. And that's why VA, velocity of the scooter, is, it is 10 plus VB. And VB, it is mentioned how much? It is 10. So 10 plus 10. So that is equal to 20. So it is 20 meter per second. So the correct option is option B, 20 meter per second. So student, we have discussed about the previous year questions of the rectilinear motions, but you need a lot of practice to develop the skill. So keep on practicing, keep on learning, and keep on watching Edora. Thank you.